Good afternoon. You've joined us on Likeable Science. I'm your host, Ethan Allen, here in the ThinkTech studios in downtown Honolulu. Likeable Science is all about how science should be viewed as a vital, dynamic, and interesting part of everyone's life, and should not be considered as something that is separate, done off in the ivory tower by lab scientists in white coats, but rather should be embraced and joyfully embraced by everyone. With me today is a very exciting guest via Skype, Dr. James Smith, and aloha, Dr. Smith.
Aloha, Ethan.
So he's joining me from actually from Huntington Beach, California, although he is actually the Henry Kinnear Professor of Environmental Engineering at the University of Virginia. And he's also the chief scientist of MADI-Drop PBC, and we'll talk a little bit later about what MADI-Drop is. It's a very exciting venture that he's started here. Jim got his PhD from Princeton University and has been a faculty member at University of Virginia now for 22 years. His research has focused on the fluid flow, and particularly how solutes and microbes can move through porous media. And for the last 10 years, he's been really looking at a specific point of interest to me. He's been studying how to sort of use these ideas and this knowledge from his research in the developing world to make point-of-use water purification or water decontamination technologies. And so he has studied ceramic filters that many people may be familiar with. Some of these get impregnated with silver to be more effective decontamination devices, but he's now really developed this really very revolutionary idea of a new, very inexpensive, very simple way to deal with this issue, a thing called the MADI-Drop, and he's going to tell us about that today. So again, welcome, Dr. Smith, and maybe just start by giving us sort of the 30,000-foot view of what is this porous ceramic tablet, MADI-Drop.
Sure, thanks, Ethan, and certainly I appreciate you having me here on your program. I really appreciate that. You know, basically what we're trying to do is tackle this problem of global water quality, and probably as you and many of your listeners know, that unlike the United States, where we generally have high quality water that's chlorinated, in the developing world, many people are drinking untreated water, and what that results in is microbial infections, people getting sick, gastrointestinal infections, and the biggest problem is the children. Probably on the order of 1 million children die each year from this problem. And what even worse than that is that there's a lot of people that we know that gastrointestinal infections caused by waterborne pathogens cause growth stunting and cognitive impairment in children. So basically, we're trying to figure out a way to solve this problem. And one of the things that groups like the World Health Organization have suggested is that we can use a decentralized approach to water treatment. What that means is we want people to treat their water in their homes right before they consume it. And that's where the term point-of-use water treatment comes from. And we've actually developed a new technology. It's a ceramic tablet. It's porous, and it's got silver inside of it. And the idea is you take this water, this porous ceramic tablet, and you place it in your water storage container in your home. And it gradually releases silver ions, which then disinfects the water, making it safe to drink. Excellent. And we think the advantage of this is it's a low-cost technology, and it's also extremely easy to use. So we think it's got a lot of great things going for it, and it may help to address this global water quality problem.
Super. That's great. And indeed, in the work that I do, I've run into exactly the issues that you talk about. A lot of my work through my National Science Foundation grant, Water for Life, takes place in some of the more remote Pacific islands in Micronesia, Chuk and Yap states particularly, along with Palau and the Marshall Islands. And yes, there's a lot of people there who drink rainwater and either have to go to the trouble of boiling it, taking time, using precious energy to sterilize it that way, or else drink it untreated. And That's, of course, does open things up. They have rather bad rates of contaminated water. A survey a few years ago in the Marshall Islands pointed out that about 3/4 of the rainwater catchment systems there had unacceptable levels of coliform bacteria in them. And so that means a lot of people there are drinking really bad water. And yes, kids are missing school, adults are missing work. As you say, there's long-term effects if you have these infections in children at a young age. So this technology is much needed.
Absolutely, and I think you're describing the situation very well. It's a typical scenario is someone goes to a river and collects water, or maybe even goes to a standpipe, fills up a large container of water. They bring it back to their home. They maybe pour it into a 20-liter painter's bucket, and that becomes their water supply that they use throughout the day in their home. And it may be a case where children are taking a cup and dipping it, and their hands are getting in the water. And even if it started out clean, which often it's not, it then becomes recontaminated during the time that it's in the home. So because there's no residual disinfectant, unlike the water we have in the United States where we've got a chlorine residual running through the spigot. That's not typically the case in the developing world. And probably on the order of 3 or 4 billion people, don't have what we have in the United States. Our water is chlorinated, it's highly regulated, it's always on, right, 24/7. In the developing world, sometimes the water isn't running for days at a time, so when it does run, they have to collect large volumes and then store it for those several days.
Right, exactly. And this certainly is true in my visits to the sites there. Sometimes the water systems break down and they only are only pressurized a municipal water system for a few hours a day, if that. There's apparently lots of people have illegally tapped into these systems so that the system, while they may have actually treated their water and gotten it reasonably clean to start with, the water gets recontaminated even in these municipal systems. So again, there's a lot of value, as you point out, in this point of use idea. The person's going to gather the water, they're going to put it in a container, and then they're going to drink it. And that seems like a very sensible place to treat it, because it's sort of, you're not cleaning unnecessary water that's being used for secondary purposes, but you will clean the water that you're going to consume.
Absolutely. So I think technologies. The thing that's needed here is that if you are going to decentralize water treatment and let people treat their water in their own home, the technology, it actually becomes a very difficult design problem. Basically what people need is they're going to need something that of course is technologically effective, right? It's got to remove or deactivate the pathogens in the water, but it's also got to be really simple to use. It's going to have to be extremely inexpensive. Many of the target users are people that may be only making a few dollars per day. And maybe the hardest thing is it's going to have to be socially acceptable. People are going to have to be willing to use it and accept it. So those, from an engineering perspective, those are extremely difficult design parameters.
Exactly, and that last point in particular resonates with me. There are places in these islands that I work that actually do have perfectly good chlorinated water. They have nice municipal systems that are very reliable, that have not broken down in sort of recent memory, that are not tapped into illegally. And so they have perfectly good fine water, and people still won't drink that because they don't like the taste of the chlorinated water. Or there's a whole cultural sort of bias against it. They think the chlorine may be toxic. They believe since their grandparents drank rainwater and were fine, and their parents drank rainwater and they were fine, they too should drink rainwater and they'll be fine. And so it's you're right, it's a very complex sort of, not just an engineering design problem, but a whole social acceptability problem.
Yeah, exactly, Ethan. And that's, particularly I know from my experience in Asian cultures, that chlorine taste is often very much unacceptable. We know the chlorine works great, but it's just, you know, if you're not used to having that material, it becomes a social problem, and people won't want to use that technology if it makes the water taste unpleasant.
Yeah, exactly. I've been surprised to see how powerful that is, considering the clear and obvious value of drinking clean water as opposed to drinking contaminated water. But it is that way. So this was what sort of drove your research initially, was trying to balance out all these different points, right?
Yeah. So we basically, you know, I've been for quite some time doing work with ceramic filtration technology. So again, I know, are aware of this, and maybe some of your viewers, that, you know, groups like Potters for Peace over many, many years, and with a lot of different people, have developed ceramic filters that have been impregnated with silver nanoparticles. And they basically have developed methods to teach local communities to make those filters and then sell them. And then it becomes a local source of revenue, so it improves local enterprise while also ideally improving the water quality and health of the community. Back about, you know, 8 or 9 years ago, I became interested in that technology. And to be honest, I originally didn't think it was going to work. There wasn't a lot of data showing those filters worked, and yet Potters for Peace was teaching people how to use them. And I actually got involved in a number of laboratory and then field tests. And what we actually found was that it works quite well. It does a good job of removing pathogenic organisms from water. And we, to the point where we were so interested, we even did a human health study in South Africa. And again, we found very clear human health benefits. We went on to actually create our own ceramic filter factory, and there's a group that's called Purification that I'm involved with that has helped create that factory, and we're actually working on creating several factories in South Africa. But in doing that, one of the things that I noticed is that these filters are not that easy to make. You know, it sounds like it's a simple process, but it actually can be quite challenging. And the people learning how to make it may require months or even years of training before they do a consistently good job of manufacturing the filters. The other thing is that the filters are big and heavy and fragile, so they're very difficult to transport. So if you're going to sell those filters, you really have to have local factories that are just serving the local community. And the other thing that's a downside about the ceramic filters is that the capital cost to buy one initially is high. You know, our factory in South Africa, the retail price is about $30 per filter. And again, for someone who's only making a few dollars per day, that's a big capital investment.
Right.
So that's where I began to think about this idea of, you know, could we just have something like a ceramic tablet that just sits in a water container and passively releases silver? Doesn't involve any filtration. The tablet would be small and durable, so it could be shipped long distances. And that was sort of the idea that drove the line of research I began pursuing about 3 years ago, where we took that idea and also some ideas of new ways of applying silver to the porous ceramic. And that's what has now eventually gone on to become this technology, which we call the Madi drop. And of course, Madi, I probably should explain to your listeners, Madi is the South African word for water. We work in the Venda region of South Africa, up north in the northeast part of the country called Limpopo province. And the Venda word for water is Madi. So pure Madi is pure water, and Madi drop is a water drop, which we just take our ceramic tablet and drop it in a water storage container.
Excellent. Well, this is very exciting, and we're gonna dig on into it a little more deeply here in just a moment. Right now, we're gonna have to go to a brief break. So you're watching Likeable Science. I'm your host, Ethan Allen, and with me today is Dr. James Smith from the University of Virginia, and we're talking about disruptive water purification technology. We'll be right back.
Hi, my name is Andrew Howard. I'm an astronomer at the Institute for Astronomy at the University of Hawaii up in Manoa. I'd like to tell you about the annual open house that we're having. This year, it is on April 6th, 11 to 4 p.m. It's an all-ages event, kids, grown-ups, even people in between. Everyone is welcome. We have a lot of really fun activities. You get to meet astronomers, look at yourself in an infrared camera, play with Legos, make robots, look at videos. You can even make some of the kids like to make comets out of gravel and snow. Even adults like to do that too. You'll be able to look at the sun with a solar camera safely. It's really a great activity. We do this every year in April, and I hope to see you this year. Thanks.
Aloha, I'm Hunter Hevlin, host of Sustainable Hawaii here at ThinkTech Hawaii. You can tune in every week on Thursday at 2 p.m. to see interviews with sustainability professionals from around the state and even further abroad, learning about activities with water management, food security, waste management, and a whole host of other fascinating opportunities to get engaged with making a greener island. So if you're interested in making the transition from consuming individuals to communities of producers, check us out every Thursday.
Hi, aloha. My name is Chris Leatham, and I host a show called The Economy and You. The show plays every Wednesday at noon. And on my show, I bring on guests who are interested or working in the technology space. And so I'd like you to come and watch the show and learn with me about all the sort of exciting things that we're doing in Hawaii to build and grow our economy ecosystem. So I'd like to say aloha, and I look forward to seeing you on the show. Thank you.
And you're back here on Likeable Science. I'm your host, Ethan Allen. We're broadcasting here from the ThinkTech studios in Pioneer Plaza in downtown Honolulu. We're talking about water purification today, specifically about a really revolutionary technology. My guest, Dr. James Smith from the University of Virginia, is joining me by Skype, and he has developed something that he calls the Madi Drop. And the Madi Drop is basically a porous ceramic tablet that's been impregnated with silver. You put it into a container of water, say a 5-gallon, 10-gallon bucket, whatever. It sits there and just slowly, over months and months, releases silver ions, which then are germicidal and kill off essentially almost any kind of the bad bugs that live in water. And so, Dr. Smith, maybe you can tell us a little bit about sort of why is it, or how is it that silver actually works as a germicidal agent?
Sure. So, you know, it's interesting, but silver has long been known as a disinfecting agent. In fact, people believe that even thousands of years ago that when civilizations would store their water in silver vessels, it was because they sensed that there was some antimicrobial or at least a health benefit of doing so. And of course, we use silver on all sorts of different technologies. It is used in things like water filters. It's used on surgical instruments. And what's really neat is that when you take silver and go from the bulk silver, which maybe has a relatively low surface area per unit mass, and you go to nano silver, where you have, say, nanoparticles that are 15 or 20 nanometers in diameter, all of a sudden now the surface area that's available for release of silver ions and then the subsequent disinfection is remarkable. So silver nanotechnology has been a huge thing in the last 10 or 15 years. In fact, if you look at all the products that involve nanotechnology on the commercial market, about 20% of them use silver nanotechnology, and it's because of its antimicrobial properties. So there are things like nanoparticles that are put in socks, nanoparticles that are used on sprays that are used on countertops for disinfection, for coatings on doorknobs and things like that. The actual mechanism of silver disinfection is actually not well understood. I mean, we know it works. We know it kills microbes very effectively, but the mechanism is a little bit uncertain. Some people believe that silver ions deactivate microbial enzymes by binding to thiol groups. Others suggest that the silver ion enters the bacterial cell and denatures some of the DNA that's in the microorganism. Regardless, though, of the mechanism, it works on a broad spectrum of microbes that are common in its waterborne pathogens, things like pathogenic strains of E. coli or Shigella or Vibrio cholera, which is the bacteria that causes cholera. Basically, any gram-negative bacteria it's very effective on. We've also got some data that suggests it's effective against a very problematic pathogen, Cryptosporidium parvovirus. This is a protozoan pathogen that chlorine doesn't disinfect. This is a very exciting result that we found, that it actually has a disinfection effect on Cryptosporidium.
Yes, indeed. And we were just looking at some graphs there up on the screen of some of your work that show basically how in the red dots, I believe it show that the amount of decrease, and that's in log units, so of the coliform bacteria as opposed to the control shown in the blue dots at the bottom. And so it's about 4 log units away, so that's a factor of, what, 10,000 fold reduction in coliform counts. So very, very potent treatment here.
Yeah, and I think the important point, too, is the time there. We can get that 3 or 4 log reduction in about 8 hours. So the idea is, the Mighty Drop is very simple to use, but the one thing you do have to do is have contact time. So, for example, what we tell people, the instructions that come with the Mighty Drop, is you place it in your water storage container and then fill it up in the evening when you're done drinking water for the day, and then the next morning it'll be ready to drink and safe. And that allows that 8-hour or so contact time to provide strong disinfection.
Right, but then the beauty, of course, of your Mighty Drops is that they are essentially reusable for, what, roughly 6 months. That is, that people can just keep adding 5 or 10 gallons of water a day to the container, and they don't have to worry about changing the Mighty Drop.
Yeah, that's correct. One of the things that we're very excited about, we originally did these experiments in the laboratory, and we do a day or 2 or 3, and it worked quite well. And then the bigger fear was, would this be a technology that could work for weeks or even months at a time? So what we did is we did experiments in the laboratory where we took a Mighty Drop, placed it in water, waited 24 hours, and then we'd measure the silver level in that water. Then we dumped the water out and refilled the container again. Right. And we repeated that procedure for 6 months straight. And every day, the silver levels came right back up to the level from the previous day. So the Mighty Drop was working exactly the same way, day after day, for 6 months straight. And that was one of the most exciting things for us, because we imagined all sorts of things that could go wrong. Things might plug the pores up, maybe something was changing with the silver release rate. And actually, we have some new data from the field that even suggests it may last longer than 6 months, even on the order of 37 to 52 weeks. So it's possible. I can't guarantee that yet. We're still investigating that, but early results from the field suggest it's working up to a year at this point.
That's stunning. That'd be so great. You could envision that whole communities would put their Mighty Drops in on World Water Day, March 22nd, and the next Water Day they'd change the tablets, and you could just make it an annual event. But that's one of the real beauties of this, as I see it, because as one of the people I was out talking a few weeks ago, I was out in Yap talking to some folks involved in this work, and the woman at one point turned to me and said, "Well, we Micronesians, we're not a maintenance culture. We don't fix our teeth, we don't fix our cars. We drive them till they run into the ground. We don't fix our teeth till we need to see a dentist." And so it's what you've developed here is a technology that's very well suited for this culture that does not like to do a lot of maintenance, where maintenance is not a sort of normal cultural aspect, because there's very little maintenance that is needed from this. So that's truly a beautiful thing.
Yeah, absolutely. And I think, that really, when you look at the different technologies that are out there on the market, this is undoubtedly the easiest to use. Once you place that in your water storage container, you really do nothing except what you normally would do, which would be fill it up when it gets empty. And the only maybe catch there is, trying to fill it up so that you allow some contact time. And that's maybe the only thing that that is a little bit more complicated than doing nothing. So I think that's a really big thing. The other thing I think that's important is that unlike chlorine, which we typically add at maybe 0.5 or 1 milligrams per liter and imparts a taste to the water, the silver, at least at the levels we use, don't have any taste to the water. So we don't change the taste of the water. So everybody's gonna, if they like the water before, they're gonna like it when the Mighty Drop's treating it as well.
Excellent. That is important because, yes, that's something you hear repeatedly in the islands is that people like their rainwater. They think the rainwater tastes better than any other water that's available. So being able to drink it and have its taste unchanged would be a very powerful incentive to use this technology. And you say also that it's quite inexpensive. That is, so you've got this ceramic tablet that's going to last 6 months. And how much is this going to cost someone?
Yeah, so the ingredients essentially to the Mighty Drop are clay, sawdust, which is normally a waste product, and our silver nitrate, and of course water we use. So the materials are actually extremely inexpensive, except perhaps for the silver. But because we're creating silver in its nano form, a little bit of silver goes a long way. So probably our projections is that it only takes a few dollars to make a Mighty Drop. Mm-hmm. And probably the retail price of a Mighty Drop would be somewhere between $5 and $10. Mm-hmm. And then when you start thinking about $5 or $10 and each Mighty Drop treats 20 liters of water per day for 6 months, right. On a cost per liter treated basis, it's really about the cheapest technology on the market today, which is very exciting. Yeah, and of course, if it lasts for a year, that even cuts it in half again, the cost per liter treated.
Exactly. No. So this seems to have a lot of pluses to it. It seems like a very powerful technology that's going to be easy to use, easy to transport, inexpensive. I don't see a lot of downsides to it, quite honestly. I mean, are there issues with it, concerns?
Yeah, so certainly I think it's certainly not a perfect technology. One of the things that the Mighty Drop doesn't do anything for is turbidity. So if your water, so turbidity, the technical definition of turbidity is the light scattering properties of water. So when you measure turbidity, you shine a light through the sample, and then you measure out what comes out the side, what's been scattered by particles that are in suspension. We know that if we grab a beaker of water from a river and hold it up to the light, it's going to look a little cloudy because of the suspended particles. The Mighty Drop doesn't change the appearance of the water. If it starts out turbid, it's still going to be turbid. And that is a downside because people, they like to be able to think that when they see clear water, that's clean water. Even though clear water can make you very sick. Right. The common perception is that clear water is going to be safe. So, more expensive technologies like ceramic filter pots or biosand filters or things like that do remove turbidity. But then again, the other thing that you can do is many people that obtain water supplies, they start out with pretty non-turbid water. Our work in Guatemala and Africa, almost all the people have water. They're able to find water with low turbidity. Right. If not, though, even things like simple fabric filtration, when you fill up your water storage container, you take a piece of laundered clean fabric, you fold it over a few times, and you pour your water through that fabric. Right. And that usually will remove most of the turbidity, and that's a very low-cost solution that's very traditional that many communities do already. Exactly. If they've got turbid water, they do fabric filtration. Exactly. But that is one of the downsides. I think one of the other downsides is that although silver works for a broad spectrum of microbes, it's not the greatest disinfectant for viruses. And of course, the virus that is waterborne that causes problems is rotavirus. Probably we're not going to see multiple log reductions of rotavirus. It does have a disinfectant effect, but not as strong as it does for bacteria and perhaps even for the protozoan pathogens. Again, though, on the plus side of that, rotavirus, there is a vaccine. And also rotavirus infection in children, although it presents with a lot of diarrhea, it tends not to cause growth stunting and cognitive impairment like many of the other infections. In Limpopo province in South Africa, where we've done a lot of our work, even in the rural villages, 50% or more of the children have the rotavirus vaccine. So that at least helps to alleviate that concern a little bit. But other than those two concerns, I think the issue of turbidity and perhaps the deactivation of viruses, I think the key more than anything is getting people to use it, which means it's got to be simple and cheap. And I think the Mighty Drop meets both those criteria better than just about anything else available. And I think that's what's really going to have a big public health.
I totally agree with you, and I look forward to discussing this a little further here. Right now, however, we're going to have to go to a break. And so I'm talking with Dr. James Smith from the University of Virginia. I'm your host, Ethan Allen, and you're watching Likeable Science. We'll be right back.
Aloha, I'm Kili'i Akina, president of the Grassroot Institute and host on Ehana Kako, a weekly program on the ThinkTech Hawaii broadcast network. Ehana Kako means let's work together. Think of the sad alternative, let's not work together. Here in Hawaii, with all of our diversity and the richness of the people, it's important for us to come together around issues on the basis of what's right and what's good and what's going to serve the common good. And that's what we try to do at Ehana Kako. Every week we interview movers and shakers, people in government, business, and other sectors of society to talk about how to create together a better government, economy, a better world here in Hawaii that can bless the rest of the world. I thank you for your attention to ThinkTech Hawaii, and we look forward to seeing you every Monday, 2 to 3 p.m. on the ThinkTech Hawaii broadcast network. We're Ehana Kako, and we wish you well. Aloha.
And you're back here on Likeable Science. I'm your host, Ethan Allen, broadcasting here from the ThinkTech studios in Pioneer Plaza in downtown Honolulu. With me today via Skype is Dr. James Smith from the University of Virginia, and we're talking about his disruptive technology in water purification, this thing called the Mighty Drop. That's a porous ceramic tablet impregnated with silver that gradually, over months and months, releases a very consistent level of silver into a point-of-use water container, that is a 10, 20-gallon water container, and thus is a very powerful disinfectant and a way to get your water clean in a very sort of simple, seemingly low-tech, although of course designing these things, as he pointed out, is a very high-tech business in a way, but a beautiful, potentially widely applicable technology. And you say you've tested this now in Africa and in Central America some?
That's correct. So we've done testing of ceramic water filters in Central America and South Africa. With respect to the Mighty Drop, our testing has primarily been done in South Africa. Of course, we've tested it in the laboratory. In South Africa, though, we have done testing in some rural villages. And what we've done, basically, we've gone into households, and each household receives 2 water storage containers. These are, 20-liter containers with a spigot and a cover. And one container has a Mighty Drop with silver in it, and one has a Mighty Drop without silver. And that's our control. And what we tell the residents is fill up both containers and use them both equally. And then we come back to the houses periodically and test water in both containers. A whole Mighty Drop that has no disinfection properties have high levels of coliform bacteria, typically hundreds, if not thousands of times above the World Health Organization drinking standard. But the containers right next to that, which have the silver Mighty Drop, have often non-detectable or extremely low levels of coliform bacteria. So we're very excited about those results. And we conducted that study initially. The first 5 weeks, we visited each house weekly. Then we visited at 37 weeks and then at 52 weeks. And even at 37 and 52 weeks, we were seeing very significant differences between the control and the silver Madi drop containers. And hence, that's one of the reasons we think our Madi drop is actually working beyond 6 months, and that even up to a year, it's still showing disinfectant action.
Oh, that's great. That's tremendous. And so I know you and I talked earlier about possibly doing some more field testing in some of the Pacific Islands here. What's your sort of growth plan for this Madi drop technology? How fast do you want to roll it on out, and what are the things, the bottlenecks in your way?
Yeah, so we are actually in the process of working to commercialize the technology. We are forming something called the Public Benefit Company, which is sort of a new entity. It's only been around for a couple of years, but it's somewhat between a corporation, a C corporation, and a nonprofit. And the idea is with a public benefit company, the number one goal of the company is not to make money. The number one goal is to do public good and have public benefit. And that's sort of our purpose. That's first and foremost is our main purpose. We'd like to get Madi drops to as many people as we can. But still in the laboratory and in the field, we still are interested in advancing the technology. We've been working quite a bit in the laboratory over the last few months to further optimize the design. One of the things we didn't really touch on is, we want to put silver into the water, but we don't want to put too much silver that it's above the drinking water standard.
Right.
So silver is a secondary drinking water standard, and the recommended limit is 100 parts per billion. So with all our experiments, we never come anywhere near 100 parts per billion. We've probably done 1,000 measurements in the laboratory and the field. We've never been above 100 ppb, which is good. So that means we're not going to cause any potential adverse effects on the people drinking that water. But likewise, we'd like to make sure there's enough silver that has a good disinfectant effect. And we've been typically operating in that 20 to 30 ppb range, but we'd like to get it up to 50, 60, 70 ppb. So we're looking at ways to optimize the design of the Madi drop. And likewise, we want to do additional field testing with those revised designs. And certainly testing it in the Pacific Islands in many of the areas that you're working, I think would be wonderful. We'd be very excited to partner with you in that endeavor and to continue to collect data on the performance of the Madi drop under some pretty challenging water quality conditions, from what I understand.
Yes, indeed. And you mentioned earlier to me when we were talking one-on-one that you've run into what I thought was actually a very intriguing challenge in that the clay that you use, apparently clay, and I hadn't really thought about this before, but clay is a natural material, so it's going to vary over time and place. So even though you are buying your clay from a standard supplier, each batch of clay is a little tiny bit different than the previous one. Probably makes virtually no difference at all in terms of standard clay uses. But for this particular use, you say you were getting a little bit of some fluctuations, and so you're looking at slightly reformulating to have better control over your Madi drop ingredients?
Yeah, absolutely. And earlier you mentioned it's a simple technology. It is, but it's not simple. It's simple to use. It's actually not simple to fully understand what's going on.
Right.
Right now, we're working with a single clay type that we've found works quite well. But even that, when you think about that clay, it's a natural deposit. It's mined in Ohio, and they move into different parts of the deposit. It may cause slight variations. Our plan, though, is right now, in the short term at least, is to perform manufacturing using this clay that we've been working with so far here in the United States. And because of, again, the durability and the small size of the Madi drop, it's easy to ship it long distances. Eventually, though, if this technology is very successful, it'll probably make economic sense to have production facilities where these Madi drops are being used, whether it be Africa or Asia or China. And in that case, then all of a sudden we're working with a different clay. And that's going to take additional research to identify the best clay and the best formulation and the best recipe to make the Madi drop effective. And that's certainly going to take some time and effort. And even with our one clay that we're working at, we still every once in a while see some puzzling things where the silver level changes and we don't know why, and we have to figure that out. The good thing is we're learning a lot, and we're getting a much more fundamental mechanistic understanding of the process. And I think that that's going to really help us in the long run to optimize the performance of the Madi drop and maintain high quality.
Yeah, absolutely. It seems that you will have a good set of sort of parameters to work around if you ever want to sort of disperse the manufacture. You'll know what to tell people to sort of look at, to do, what kind of clay might be best, what size parameters of the clay particles are probably going to work best. And if they're off of that, you may even have sort of ways to adjust for that by changing your recipe a little bit, right?
Yeah, I mean, when you think about it, I mean, there's all sorts of things. Let's just think about the clay. The clay has different mineralogy depending on what clay you pick,
right.
Different surface chemistry, and then there's different particle size distributions you can work with the clay.
Right.
Then you throw in the sawdust. We've got hardwood sawdust, we have medium wood sawdust, we have softwood sawdust. We also have different particle size distributions of the sawdust. And what happens is the whole idea is when we make these together, we're mixing the clay, the sawdust, the water, and the silver, and then we press it into the shape of a tablet, and then we fire it in a kiln at a high temperature. And during the firing process, the clay hardens into the ceramic, the sawdust combusts, and that leaves the porosity, and then the silver gets reduced to metallic silver nano patches, which are on the order of just a few nanometers in diameter. But you can imagine, since the sawdust is combusting and creating the pore structure, the size of those sawdust particles is really going to influence the release of the silver from the Madi drop. And then even just things like the water that we mix it with. If you use DI water, of course, it's just H2O, but probably you're going to use natural water. It's just less expensive to do that, and use tap water, say. And there are constituents in tap water and natural water, carbonate, bicarbonate, chloride, sodium, calcium, and what role do those things play? So there's a lot of stuff going on, even though it's a fairly simple set of ingredients. And even the kiln firing protocol can affect the release of the silver. We've done all sorts of work on different ramp rates for our kiln, different hold temperatures, and all that can affect the release of the silver ions.
Absolutely. So it's a beautiful example, again, of how in science you have the simple combined with the complex. So yes, this beautifully simple to use, inexpensive water purification technique, but there's some real subtlety and complexity in what's gone into that. As you say, the chemistry, the sort of physical chemistry and structural aspects are simply amazing. It's been great talking to you, by the by. This has been a wonderful and exciting opportunity for me to learn more about this, and I know our viewers have learned a lot too on this, so that's all to the good. And I look forward, of course, to staying in touch with you as you continue to develop these and hopefully becoming a field test site for you and getting some of these out, because I do think that they'll find a very welcoming audience in the Pacific Islands. But we are going to have to wrap it up now. So you've been watching Likeable Science. I'm your host, Ethan Allen. My guest today has been Dr. James Smith from the University of Virginia, and we've been talking about his breakthrough technology, the Madi drop, in water purification. Hope to see everyone next week. Bye-bye.